Hello everyone, good morning. My name is Surya and today I'll be talking about yet another interesting application of the Internet of Things. What I've done here is actually an intersection of different fields, primarily of networking, task scheduling, multiprocessing and home automation. Consider these situations. What if you're going to work from home and you're stuck in traffic but you suddenly realize that you have to send an urgent email to your boss? You don't have an internet connection. What do you do in that situation? Or how about another case where you need to perform some web scraping activity? For example, you need to track the instantaneous per second price of Bitcoin, Ripple and Litecoin. But one alternate is you could sit in front of a computer screen and manually track each and every second what the prices are and make your margin calls based on those observations. Or what if you could automate this? What if you could have a function that will tell you when the best time is to purchase based on certain personalized factors such as your risk probability, how willing you are to spend, what amount you're willing to spend, what margin rate you're expecting. If you could automate this, how awesome would that be? Today, I'd like to demonstrate a prototype solution that does all of this and so much more. First, I'd like to tell you about the original motivation behind this project. I'm a college student in Manipal Institute of Technology and I live in the hostels. Our institute provides us an internet connection through a third party known as ION. So in order to access the internet, we need to log in through their portal which they provided on one of their servers. After logging in, by typing in my username and password, I will now get an internet connection. As it says here, I've successfully logged in. This is the perfect example of a task that can be easily automated with the architecture I'm about to propose, which we call Helios. Let's start with the network topology. ION provides a campus-wide internet connection, and in this hostel corridor specifically, we get our Wi-Fi signal through routers such as these. Now all of that was outside my room. Here we have a repeater which I'm using to catch the Wi-Fi signal broadcasted by ION. If you follow the wire, it feeds into a router. This is a standard Netgear N600. Now, my personal area network that's hosted by this router consists of several peripherals. First and foremost, my phone. My phone is connected to this via Wi-Fi and has to remain in this personal area network. Second, we have a microcontroller. This is known in the market as an Orange Pi. It's capable of running a Linux host and it's connected to my router via Ethernet. Also, I've connected other peripherals such as my laptop, which can be connected to the router through Ethernet or Wi-Fi. So now I'll explain a visual representation of Helios' architecture. First and foremost, we have the ION router, which broadcasts a signal that's caught by my repeater. And then beyond this, the repeater feeds a direct line into my router, which then hosts a personal area network of multiple devices. As explained, we have my phone, a microcontroller, and any other devices. This can be enumerated into whichever peripherals you need to automate. In this case, it's only my laptop. Now, more importantly, we have a remote person who is going to send an SMS, which is going to be received by the phone that's sitting at home. Upon receiving this command or trigger, the phone will, I'll use a different color pen for this. The phone, after receiving this SMS, is going to send this command through the router and to the microcontroller. In this specific case, the task that I'm trying to automate is logging into ION based on this remote trigger. So the microcontroller will act on that command and forward it through the router, through my repeater, and indirectly through ION itself, like so, and perform the login operation. This is the physical topology of what's going to happen when the user sends a remote trigger through SMS. And keep in mind, there's a very interesting thing here. The phone is going to send a TCP packet that happens to the internet protocol, whereas the user just sends a simple SMS. This removes the need for the user to have an internet connection. So now, if I try and explain the actual architecture of the microcontroller, first and foremost, we have a master script. The master script is going to have three different components. First is the network watcher, then we have the middleware, and then we have the controller. I'll explain what each module is. The network watcher is responsible for receiving that TCP command. As we saw in the previous diagram, this TCP command is sent from the phone. The TCP command is then sent directly to the middleware. The middleware is responsible for doing some interpretation, some pre-processing, and converting this TCP string command into an actual command object. So at this point, it's just a string. At this time, it's a command object. Now, in this case, our task was to log into ION. We have a policy of constructing workers, one worker per task that needs to be automated. So in this case, we spawn a worker every time we want to log into ION or log out of ION. This worker is responsible for the entire operation, anything that has to do with ION itself. Now the controller is responsible for hosting a worker group, which in turn spawns n number of workers. And this n is important because now there's no cap on the number of tasks that you can parallelize and automate. So after this command is received by the controller, it will search for the specific worker. In this case, let's assume this one is responsible for handling ION. This command is then forwarded through the worker group. It searches for that specific worker, goes to that specific worker, and this worker can now act on that particular command. You can change its mode of operation. For instance, instead of logging in, now log out of it. You can change its persistence levels. For example, log in every 5 minutes, or log in once a day, or just do it as a one-off run. Any number of tasks. Now, what we demonstrated here was a worker-specific command. This can also be a controller-specific command. For example, if you want the entire controller to shut down, for instance, or even restart, you can send a shutdown command to the controller. If the controller detects that this message is meant for him, then he won't bother broadcasting it to all the individual workers. It'll instead just perform a direct shutdown. So this will terminate and therefore report to the master that we've now officially shut down this entire architecture. So this layout should elaborate what the microcontroller is doing, what it's composed of, and how a trigger can be sent from a remote access point and interact with individual workers or the controller itself. And now, for the actual live demonstration of the Helios architecture. Here, we've considered two sample functions. One is responsible for the logging in and logging out of the ION portal. And the second is just a demonstration function. Here, as you can see, it's just a function to square a number. And the default argument is the number 3. And here we have the ION login function. So now before we fire up the automation script, let's just verify if I'm connected to the internet or not. No, I'm not. It's asking me to log in using my credentials. Let's just verify that. If I connect to google.com. No, it redirects me back to the ION portal. So now let's boot up the microcontroller and launch the automation script. First I need to log in via SSH. 10.0.0.5 if I'm not wrong. Yeah, I have successfully logged into the Orange Pi. So change my directory and launch the automation script on port 9097. Alright, looks like we're ready to go. So now, as you can see here, the controller is now waiting for a command. Now, this is a friend's phone, and I've preloaded some messages just in the interest of this demonstration. I have a command to log into ION. I'll forward that to the Helios controller. Let's increase the brightness a little bit. Yep, and as you can see here, it did receive the command to log in and it's already started this process. Of course, what happens inside this is specific to the function itself. Now, we've launched the ION worker and its current execution mode is to log in. Let's try and change its mode to start logging out. The syntax for that is ION at Helios, whose mode is log out. Forward that to Helios. And upon reception, we see here in the terminal output that it received a command for logging in the logout mode. and now it stopped the executor before logging out. So now we've seen that we're able to change the mode of operation dynamically. And all of this is happening through remote access, strictly through SMS. Now, what if we had to execute multiple workers in parallel? That's possible as well with the Helios architecture. Let's try logging in again. And upon reception, yep, it got a command to log in. And just to verify that, let's try talking to google.com right now. Yes, we do indeed have internet connection. If I reload the Ion portal, it too will reflect that I've logged in. I'll just verify that. Yep, we can see here that my registration number is autofilled, meaning I have logged in using my credentials. So now let's try and launch another script, that is, in our case, the square function as f square at Helios. Forward this to Helios and send. Let's look at the terminal. And upon reception, anytime soon, yep, we see that the square function also is happening in parallel. And the wonderful thing about this is each of them are completely independent of each other. One is running with an interval time of 1 second, and the other is working with an interval time of 5 seconds. That was specified in the command itself as the retry interval argument. So what does this mean? We have the ability to now run multiple workers completely independent of each other, unlimited in nature, and completely in parallel. Now, the different commands we sent via SMS right now were worker-specific commands. Now, let's try and send a controller-specific command. So, in this case, I'm going to try and shut down the entire architecture. Not a worker-specific thing, but for the entire system altogether. So, the syntax for that is Helios mode is equal to shut down. I'll forward that to myself. Helios send, and waiting for it to receive. Yep, and we can see in the terminal output that the main thread did indeed exit because it received a shutdown command. So now we know that we have the ability to send worker-specific commands as well as controller-specific commands. This gives a little bit of diversity to the type of functionality we can program, and all with the help of a simple SMS. No internet connection required from the end user. You just need a phone with cellular reception. In a nutshell, the Helios architecture is completely scalable to any automation solution. There are 4 major reasons for its elegance. First and foremost is the fact that you can have unlimited number of workers that are executing for your automation. It's not limited. The second reason is all of these are executing in parallel. There's no sequential dependency from one worker to another. Meaning, no matter how many you have, you can expect a similar amount of performance. The third reason, and this is really important, is the fact that you can have remote access to this home automation solution, no matter where you are in the world, as long as you have a cellular reception. And the fourth reason, and this is my personal favorite, is the fact that you can copy-paste any Python function, as long as it can run on your system. If you can figure out a way to make it run on your Linux system, you can make it run here. And that's my favorite because now anything can be executed. It can be a task so simple as, for example, my smartwatch. Every night, I can make it automate the sync and backup to an online cloud. This removes the need for me to manually swipe and sync on my phone every night. And like this, there are many other solutions that I can automate every single day. For this reason, I think this sort of an IoT solution, Internet of Things, is going to be extremely important in today's world. And of course, this is still in the prototype stage, and I'm definitely going to keep working on this. If you have any ideas, any automated solutions that you think would probably be a great thing to implement, I'd love to hear from you. Please leave your ideas in the comments below, or definitely you can get in touch with me through any other means. Thank you so much and have a great day.